Hello, my name is Daniel Perez Zúñiga. I'm a student at UNAP in the field of electronic engineering with the course 24-2024-1. Today we will talk about the calculation of magnetic flux in the motor with terms. General actuality of the exercise. To analyze how the magnetic flux and the induced electromotive force behave in a motor with terms and the function of time using electromagnetic concepts such as magnetic flux, Faraday-Lenz Law, and induced current. 1. The definition of variable. The radius of the coil is 5.10 meters. The area of the coil is 81.74 square meters. The magnetic field vector B is 13 in the I direction, minus 4 in the J direction, plus 9 in the K direction in Tesla's unit. The angle is theta, which equals 280 degrees. The frequency is 5,820 Hz, and the number of stairs is 20. 2. Calculation of magnetic flux. Phi should be equals the magnitude of B times the magnitude of A times the cosine of theta. Replacing values with weight. The magnitude of B is the square root of 13 square plus minus 4 square plus 9 square, with the square root on the 266 equal to 16.31 Tesla. Substituting into the flux formula, phi should be equal 16.31 Tesla times 81.74 square meter times the cosine of 280 degrees. Cosine evaluation. The cosine of the 280 degrees is approximately 0.176, resulting in the magnetic flux on 231.41 joules for 1/3. Total flux for NQ 23. Find some B on the T equals 20 times 231.41, resulting in the 4,628.2 joules. Why analyze the magnetic flux and fraction of time? We use formulate the relative the number of the third magnetic field, magnitude the area, and the cosine of the angle varying with time. First one calculates the angular frequency omega, which is equal to 2 pi times the frequency. In this case, the frequency is 5,820, with waves angular frequency of 36,25,164.8 radians per second. The wave plus the values into the flux formula will multiply 10 times 60.31 Tesla times 81.74 square meter times the cosine of omega times the with 26,664.3 times the cosine of omega t. We evaluate specific time values. When time is 0 seconds, cosine of 0 is 1, so magnetic flies in 26,664.3 universe. When time is 10 seconds, cosine on the 365,614 radius is approximately minus 0.2713. Flat is approximately minus 7,232 points my square base. For 60 seconds, cosine of 2,193,888 radian is approximately 0.4987, resulting in the flies on the 13,294.7 GHz. The weight has for one value of time that when the same flies is when the angle is 280 degrees. We convert that angle to radians, approximately 4.869 radians, dividing that by the angular frequency used the time, approximately 1.336 times 10 to the minus 4 seconds. Now we calculated the induced electromotive force using Faraday-Lenz Law. The induced electromotive force is obtained by multiplying the number on the term by the magnetic field magnitude, the area, the angular frequency, and the sine of omega t. Replacing of values while when that the induced electromagnetism for equals 9.73 times 10 to the 7 times sine of omega t. Finally, we calculate the induced current and the moment when the time equals 16 seconds. One use of law when the current is equal to the battery voltage minus the electromotive force divided by the resistance. The battery has a voltage of 9 volts and the wall resistance is 100 ohms. We calculate the electromotive force for 16 seconds. We multiply omega by 16, which finds 185,036.8 radians. The sine of the angle is approximately minus 0.7687. Multiplying the sine by 9.73 times 10 to 7. We obtain an electromotive force of the approximately minus 725,623.8 volts. Then the induced current equals 9 minus 750 million, all divided by 100. This results in the current of 7,106,256.33 amperes. General conclusion of the exercise. This exercise shows how magnetic flies and induces EMF vary in the motor as fraction of the time. The value on the induced current can become extremely high in the harsh non-limited components, which theoretically highlights the importance of magnetic field variation in electromechanical systems. Thank you very much.